We will see a SLA compliance report for traffic between node A and node C generated using data collected from in-band OAM. Node A and node C can represent edge of an enterprise site connected over WAN over a provider's network. iOAM is enabled to collect tracing and sequence number as well as verify proof of transit via different paths in the provider's network. Node A adds iOAM data into the packets going through it, while Node C extracts the data from the packet and exports it into the server for further analysis. What you see here is a simple dashboard application that we have created that accepts threshold value for compliance and generates the report by querying the Elasticsearch, which is collecting the data from the in-band OAM data exported by Node C and indexing it and storing it in its database. Simulated network in Viral to generate the SLA compliance dashboard. We have VPP1, which represents node A, and VPP3 represents node C. VPP1 adds IOM data for all the traffic passing through it, and VPP3 extracts IOM and exports it to the server. We have a collector running on server which collects the IOM data and passes it on to the ELK stack, where it is indexed and stored in Elasticsearch. We have a continuous flow of traffic from host 1 to host 2 using the traffic generator. We also simulate a lossy link between VPP1 and 2 by configuring a link for packet loss in Viral. We initially had the routing configured on VPP1 such that all the packets from host 1 towards host 2 were taking the lower path via the slow link introduced by the shaper. And then we switched to the upper path, which is VPP1, 2 and 3, which is also the compliant path in terms of proof of transit. The dashboard application is continuously querying the Elasticsearch over REST for the current path compliance, which will be reflected in the dashboard. This is the dashboard that we see according to the settings for the target delay and jitter. And what we see is currently it is taking the lower path, VPP1, 2 and 3, which is as per the routing configuration. And since the link 1 to 2, that is between VPP1 and 2, is lossy and we have configured a 10% packet loss, we see the compliance reflecting accordingly. The path compliance is 100% because VPP1, 2, 3, that is the upper path, is compliant. And there is no delay and jitter against the threshold value that is set. Historically, since it was taking the lower and the slower path earlier, we see that there was delay and jitter compliance deviation and there was 0% path compliance.